morning to all of you. First of all, I want to introduce myself. Myself Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering, Vahelal. And today my content is GTU question paper solution of the subject of calculus of June 2013. So up to question number 3B, 3A, we already seen this question paper. So let's start with question number 3B. Here is a question number 3B. State Leibniz rule to find the derivative of g of y, that is equal to integration root y, integration from root y to 2 root y sin square t dt. So first of all, we have to understand that what is a Leibniz rule. We have to write down the statement of Leibniz rule, and let's see how we solve this example. So let's see on Teletalk. Here is our Leibniz rule. If f is continuous, on closed interval AB, and u of x and v of x are differentiable function functions of x whose values lie in closed interval AB, then d by dx of integration u of x to v of x f of t dt, that is equal to f of vx dv by dx minus f of u of x into du by dx. So we have to apply this formula. This is a Leibniz rule. If f is continuous on closed interval AB and ux and vx are differentiable function of x whose values lie in closed interval AB, then d by dx of this integration ux, integration from ux to vx f of t dt, that is equal to f of vx dv by dx minus f of ux into du by dx. So to solve this example, we have to apply this formula. Just try to remember d by dx integration ux to vx f of t dt, that is equal to f of vx dv by dx minus f of ux du by dx. So here our function g of y is, you can see our function g of y is root y to 2 root y sin square t dt. So by applying Leibniz rule, g dash y, that is equal to g dash y is equal to, you can see ux is equal to root y, right? Here you can see ux is equal to root y, vx is equal to 2 root y, and function f of t is sin square t. Our function f of t is sin square t. Okay, so this is our formula. You can see d by dx of integration ux to vx f of t dt, that is equal to f of vx dv by dx minus f of ux du by dx. So f of t is sin square t, and v is equal to 2 root y, u is equal to root y. Okay, so using this formula we get f of 2 root y d by dy of 2 root y minus f of root y into d by dy of root y. Okay, now this equal to, because of f of t is equal to sin square t, so instead of t we have to put 2 root y, so that's why this equal to sin square 2 root y d by dy of 2 root y. So derivative of this function, we know that derivative of root y with respect to y, that is 1 upon 2 root y. So this become 2 upon 2 root y, this 2 will be cancel out, minus f of root y, so that is sin square root y, and this is derivative of root y with respect to y, so that is 1 upon 2 root y. Okay, now this equal to 1 upon, this is 1 upon root y, this is 1 upon 2 root y. If we write down this term very properly, then 1 upon 2 root y will be common. In bracket we get 2 sin square 2 root y minus sin square root y. So this is our answer, 1 upon 2 root y, 2 sin square 2 root y minus sin square root y, right? So this is the derivative of the function where g of y is equal to integration root y from 2 root y sin square t dt. So here we complete the solution of this example. Let's see next example. Question number 3c, evaluate the integration from 0 to pi by 4 sin 2 theta raised to 7 d theta, and the second example is integration from 0 to 1 x raised to 7 upon under root 1 minus x raised to 4. So to solve this example, this is an example of a chapter of reduction formula, and we know that reduction formula, that is integration 0 to pi by 2 sin theta raised to n d theta, that is equal to, that is a formula, that is n minus 1 upon n into n minus 3 upon n minus 2 up to 1 by 2 into pi by 2 if n is an even, and the same formula, but if n is an odd, this formula goes to 2 by 3 into 1. So let's see how we solve this example and total it up. This is the question number 3c, the first part, that is integration 0 to pi by 4 sin 2 theta raised to 7 d theta, that is equal to, now here we apply this formula, integration 0 to pi by 2 sin theta raised to n d theta, and the same formula is applied for cos theta, 0 to pi by 2 cos theta raised to n d theta, that is equal to n minus 1 n minus 2. If you want to remember, up to 1 by 2 into pi by 2 if n is an even. If n is an even number, then this equal to, and if n is an odd, then n minus 1, n minus 2, n minus 3 up to 2 by 3 if n is an odd. If n is odd number, then so we have to apply this formula. But in this case you can see our integration is compulsory from 0 to pi by 2, right? Then we can apply this formula, either n is odd or even, then we can apply this formula, otherwise we cannot apply. But in this case you can see our integration is from 0 to pi by 4. So using some method we have to convert this integration from 0 to pi by 2 and then we can apply. So let's starting with 2 theta is equal to t. Let's take 2 theta is equal to t, and then we can understand that then our integration is from 0 to pi by 2. So just remember this formula, we are applying this formula. Now this is our example, 0 to pi by 4 sine 2 theta raised to 7. So and this equal to, let 2 theta is equal to, let 2 theta is equal to t. So clearly from this d theta is equal to dt by 2, right? Differentiating with on both the side. So d theta is equal to 2 d theta is equal to dt. So d theta is equal to dt by 2, and the limit, you can see limit also will be changed when theta is equal to 0. When theta is equal to 0, t is 0, and when theta is equal to pi by 4, then t is equal to, theta is pi by 4, so 2 into pi by 4, that is pi by 2. So now if we can say this is I, this integration is I, then I, we can write down I is equal to 0 to pi by 2 sine t raised to 7. Instead of d theta we can put down dt by 2. So 1 by 2 into dt. Now we can apply this formula. Now we can apply this formula. You can see this formula we can apply. Integration from 0 to pi by 2 sine theta raised to n, that is equal to, now here n is equal to 7. So when n is odd, 7 is an odd number, right? So we have to apply this formula, n minus 1, n minus 2, n minus 3 up to, that is equal to up to 2 by 3 if n is an odd. So n is equal to 7. So the answer of this example is 7, 6, 5, 4, 3, 2, right? So this equal to 1 by 2, this 1 by 2 is as it is, into 7, 6, 5, 4, 3 and 2, right? So this is our answer, and this equal to, you can see this equal to 8 upon 35. This is 8 upon 35. So this 2 will be cancel out, this 3 into 2 6, right? 4 into 2 8 and 7 into 5 35. So the answer of this example is 8 upon 35. Same type of example, the second example, you can see the integration 0 to 1 the integration 0 to 1 x raised to 7 upon under root 1 minus x raised to 4 dx. Now let x square is equal to t. Let x square is equal to t. So from this term we get 2x dx, that is equal to dt. Okay, and x dx, that is equal to dt by 2. Okay, now when x is equal to 0, t is also 0, and when x is equal to 1, t is also 1. When x is 0, this t is equal to 0, and when x is equal to 1, this t is equal to 1. Okay, now if this is I, then I is equal to now integration 0 to 1. This is x raised to 6 into x, right? This x raised to 7 can be written as x raised to 6 into x. Now x dx, that is equal to dt by 2. So this is equal to dt by 2, and x raised to 6, the remaining term in the numerator is x raised to 6. Now x raised to 6 can be written as t raised to 3, because x square is t, right? So x square is t, so x raised to 6 can be written as t raised to 3. So t raised to 3 upon under root 1 minus t square. Okay, t cube. So the integration 0 to 1 by 2, 1 by 2 integration from 0 to 1 t cube upon under root 1 minus t square.